Meet Philip, who loves mac and cheese. Sometimes Philip even eats a whole box of mac and cheese for lunch. But his friend Jerry tells him that it's going to take a long time for his liver to break down the toxic yellow dyes present in the mac and cheese. But Philip believes otherwise. He thinks that the liver will work faster to break down the dyes. To prove Jerry wrong, Philip decides to test whether the concentration of the substrate affects the activity of catalase. His hypothesis is that an increase in substrate concentration will also increase the activity of catalase, as an increase in substrate concentration will increase the rate of reaction between the substrate and enzyme. Philip has decided he will test substrate concentration by performing an experiment using hydrogen peroxide as the substrate and catalase as an enzyme. First, we will take our sample of catalase by picking up a paper disc with a pair of tweezers. Afterwards, soaking it in catalase, we will make sure both sides are well drenched. Next, we will take our hydrogen peroxide and our water and transfer it into a graduated cylinder. This will be done with varying amounts of hydrogen peroxide and water for different substrate concentrations for the experiment. Afterwards, the solution of hydrogen peroxide and water will then be transferred to the reaction chamber. Once finished, take the sample of catalase retrieved earlier and place it at the top side of the reaction chamber, making sure it does not come in contact with your solution. Next, cover the reaction chamber with a tube to stop. Fill up a tub with water and invert a 50 milliliter graduated cylinder in the tub. Slide the tube on the stopper under the graduated cylinder to ensure that released oxygen will flow into the cylinder. Then, invert the chamber to begin the reaction. By inverting the chamber, the dish soaked in catalase and the hydrogen peroxide will come into contact and begin reacting. Measure the amount of water displaced by the oxygen gas, released every 30 seconds over the next 3 minutes. This is a table of the data that was collected. This data demonstrates how a greater concentration of hydrogen peroxide directly correlates with a higher rate of reaction. Hydrogen peroxide naturally decomposes into liquid water and oxygen gas on its own, but the decomposition takes a very long time. When our hydrogen peroxide solution comes into contact with the catalase-soaked disc, the catalase catalyzes the decomposition, rapidly increasing its rate of reaction. As shown in the graph above, the results do fit Philip's hypothesis, as when the concentration of our substrate, hydrogen peroxide, was increased, there was a notable increase in the rate of reaction.